Hey, this is Steve, and today I'm in Paris at the Gas Analysis 2026 event. And I've got the pleasure of being able to talk with Manohara from the NPL in Teddington, London. And he's been doing some incredibly important work related to CO2 gas purity analysis and measuring CO2 to help people do carbon capture, storage, transportation and sequestration. Manohara, it's lovely to have you here. Say hello.
Nice to meet you, Stephen.
Thank you. And I tried to summarize the work that you've been doing there, but look, tell us in your own words, what have you been up to, what's the project, who's been involved, and what have you specifically been doing?
So at NPL, we have been developing metrology necessary for supporting carbon capture, storage and utilization area. So we developing gas reference materials, analytical methods, and also we developing material testing platform for assessing various capture materials to make sure they perform the job that they meant to be doing. And also we are looking into various sampling kits. So we are also looking into various calibration aspects of analyzers to make sure they're fit for the purpose.
Okay, so that was 3 real streams of work that I heard you talk about there. Let's break it down and let's just talk about the first one to start with, CO2 gas purity analysis for CCU, CCS. Why is it important to measure gas purity, and what are we really trying to measure in there?
Okay, so CO2 quality is central to across the supply chain of a CCS value. If you look at the capture, storage, transport and utilization application, because we are talking here not just a pure CO2, we do have up to 4% of different impurities. So at this point we know there are up to 70 different impurities from trace level up to percentage level, and then they change based on the your source, where you emit, and and also they can change based on the sink where they need to store. So each project has its own specification, what they can let in the pipeline and store and what they can't. So in order to make sure, so we do have a confidence in the stream, so we need to measure them, not just a 96% of a CO2, we also need to measure those 4% of impurities. Those impurities of a different nature. Some may be inert materials like nitrogen, hydrogen and argon. They have their own impact on the flow of CO2, in terms of phase diagram, in terms of controlling storing underground, and they also have various toxic or hazardous components like SO2, NO2, water and oxygen. These things can pose risks to infrastructure integrity, like corrosion. They can also create health and environment problem for when they leaks out of the pipeline and storage site. So they need to be assessed accurately and accounted for in order for people who transport and store to have confidence and build a necessary infrastructure or necessary controls in place in case if they get leaked out. So that's why those needs to be measured accurately. And it's not just measuring them. What's important is those measurement needs to be traceable back, so that people have confidence in the technology and also give confidence to governments, public as well as the investment, so that they can rely on CCUS for a energy transition.
Okay, thank you. And at the very beginning there you talked about inert gases, let's say methane, nitrogen, hydrogen. Well, if they're inert, what's the problem? Why do we care about those in particular?
So they pose a risk for operational transportation, because you need to design a system where you transport a CO2 when you have a percentage level hydrogen. For example, the phase boundary of a CO2 is drastically changes. And then as an operator, as an engineer, so it'll let you have a lot of challenges to predict the phase of CO2, how much mass has been flown, designing flow meters, probably accounting them accurately in order for either to tax people who emit CO2 or incentivize people who transport it. So we're talking here billions of maybe trillion tons of CO2, not just 1 or 2 million tons of CO2. So that's when the scale and impact of those impurities will come to play, even though they are just we're talking percentage levels.